Today we're going to talk about the quadratic formula, which is another way that we can solve a quadratic. So we're going to start with this situation right here. What if you were trying to solve a quadratic and it wasn't factorable? Example, a baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second at an angle of 45 degrees with respect to the ground. The path of the baseball is given by this function, where f of x is the height of the baseball in feet, and x is the horizontal distance from home plate in feet. So the question is, or should be, where does the ball hit the ground? Now, if you take a look at the function right here, and think of the method that we learned the past few days of factoring, though this is not going to be very fun to factor, and so we're going to learn another method that we could use to solve this function instead of factoring. That method is called the quadratic formula, and today we're just going to practice using it, and we'll practice applying it more and talking about what it means tomorrow. So the quadratic formula, we'll go over what the formula is, but we're going to practice chunking it into three main parts. We'll call the three musketeers. Let's take a look at what the quadratic formula is. Now, in order to use the quadratic formula, you need to put it in something called standard or general form. So standard form is when all of the variables and coefficients are on one side and 0 is on the other. Again, we're trying to solve for the zeros. And you put it in order from the highest power down. So we have an x squared and then an x, and then you have just the x to the 0 power last. And here's the three musketeers. We'll come back to this after we look at the quadratic formula. So here is the quadratic formula. It would be x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And here are the three musketeers that you want to keep together when we're solving. You have the opposite of b, you have the b squared minus 4ac, and you have 2a. So we'll call these the three musketeers, and we'll practice solving each part of these before we use the equation to find the answer. Now there's a song that we sing in class, but since my voice is kind of going, I'll play it for you right here. There's actually a lot of songs on YouTube. Let's see if it'll play. Let's try reloading it. Here we go.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
So we sing this in class, except instead of negative b, we say opposite b. So I'll play it again for you.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
All right, so we're going to practice using this. And again, we'll practice chunking with the three musketeers, we'll call them. I have a sheet in your note packet. Let's see if I can find it here too, that we'll use to solve. And it makes it easier to kind of show your work. Let's find it. So we'll open this. It might take a second. And we'll use it to factor this one right here, x squared 5x plus 6. And we should go over what a, b, and c are. So if you put the equation in general or standard form, it's ax squared plus bx plus c. A, b, and c are the coefficients. A is the coefficient of x squared, b is the coefficient of x, and c is the coefficient of x to the 0, which doesn't show up. All right, let's go to this right here. I'm going to make it bigger. And we'll practice using quadratic formula. Let's see if I can make it bigger. I guess it won't let me zoom. There it is. Okay, so here are the steps for quadratic formula. First step, put it in general form. Find the values of a, b, and c and calculate the three musketeers. Let's do the work here. And let me find what function that we want. All right, let's do it for x squared plus 5x plus 6. Okay, so x squared plus 5x plus 6 equals 0. So let's say you want to solve this using the quadratic formula. We're looking for the x-intercepts. First step is to find a, b, and c. So a is the number in front of the x squared. So here a is 1. B is the number in front of the x, which is 5. And c is the number by itself, which is 6. All right, so here are the three musketeers, and we're going to plug into the quadratic formula, and we'll solve. So I'm going to move this down. So here's what I should see for the work when you're doing this on your assignment and also on your any test or quiz. So we have x equals the opposite of b. So if we look at b, the opposite of b would be negative 5 plus or minus the square root of b squared, so negative 5 squared, minus 4 times a, which is 1, times c, which is 6. And use parentheses around these right here. And that's all over 2a, and again, a was 1. So I would want to see what you're plugging in. Now here are the three musketeers that I want you to keep separate. So there's the first musketeer, here's the second, here's the third. So again, I would want to see this step on your paper. Negative 5 plus or minus the square root. And then if you do this chunk in your calculator with parentheses, it should calculate for you without any errors. Again, use the parentheses, but we see that negative 5 squared is 25 minus 4 times 6, which is 24. So that's 1. So I want to see that all over 2 times 1, which is 2. So I want to see these three numbers separate. Step 5 is to solve or simplify for the two roots. There's two answers, the plus and the minus. So we're going to split this up into the two roots. So the plus solution is negative 5 plus the square root of 1 over 2, which is negative 4 over 2, which is negative 2. And the other solution would be negative 5 minus the square root of 1 over 2, which is negative 5 minus 1, so negative 6 over 2, which is negative 3. So what we've done is we found the x-intercepts, or the zeros of the graph. If we were to sketch the function, you would have a 0 at negative 2 and 1 at negative 3, so your parabola would look something like this. Okay, so we're going to practice this a few more times. Let me go back to our PowerPoint. Okay, so we did that one. Let's try this one right here. Solve using the quadratic formula. First step, identify a, b, and c. So a is 1, b is 5, c is 3. And again, you can identify when zeros on one side. We're trying to find the zeros. Next step, plug in. X equals opposite b plus or minus the square root of b squared, so put that in parentheses, minus 4ac all over 2a. All right, I want to see your three musketeers, so these three chunks right here. Calculate these guys. So you get negative 5 plus or minus the square root. This would be 25 minus 12. And then if we calculate that, 25 minus 12 is 13. All over 2 times 1 is 2. Now we split it up into our two answers. We had negative 5 plus the square root of 13 over 2, and negative 5 minus the square root of 13 over 2. And we're going to practice simplifying radicals tomorrow. So then we're going to solve. We'll just find an approximate answer for each of these. So if we type these in our calculator, one answer is approximately negative 0.70 if we round. And this answer right here is approximately negative 4.3. So here are two zeros. And if you were to sketch that function, one would be at about negative 4.3, and one would be at negative 0.7. So here would be your parabola right there. Oops, is that all we have? No more practice. Let's see. Yeah, it looks like that's it. Let's go back then to the starting problem so we can apply quadratic formula to this. So again, we have this baseball that's hit with a certain velocity, and we want to figure out how far the ball is from home plate when it lands with this equation right here. So let's practice using quadratic formula. So we want to find when it lands or when the height is 0. So we can set 0 equal to negative 0.0032x squared plus x plus 3. Find a, b, and c. A is negative 0.0032. B is 1. C is 3. Plug into quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a Find your 3 musketeers, so your 3 chunks right here. You're going to calculate x equals negative 1 plus or minus the square root of 1.0384 divided by negative 0.0064. And when you type this in your calculator, hit enter before you divide, you get 2 answers. If I calculate this correctly, I get 315.47 feet, and I get negative 2.97 feet. So in the context of this problem, only one answer makes sense. Your ball lands about 315.5 feet away from home plate. So today is just practicing. Can you plug into your quadratic formula and find the answers? And we'll practice applying quadratic formula and also simplifying radicals in the following days.